All right, we're going to talk about something a little bit more difficult. And we just got done with the mode and the median and the mean and the range. We're going to use some of that learning and apply it into the measures of variation. Okay? It's going to be a lot of vocabulary that we're going to have to work on here. So I got this page of our book, and I'm going to circle some words that are important. Quartiles. Values that are divided into 4 equal parts, like quart, quartet, quart, 4. So that equals 4 different parts. Okay. And then we're going to be talking about the first and the third quartiles. So when you have something broken into 4 equal parts, you have a first, a second, a third, and a fourth. But the main ones would be the first and the third. Okay. And then once we know these first and the third quartiles, they are the medians of the data values less than the median, and the data values greater than the median, respectively. Whew, that's a lot to think about. So basically, you have, I'm going to move this over like here. If you have something like this, I don't want to do that. You have something like this, and now I'm going to break it into 4 equal parts. I'm going to find the very middle of it. Okay, that I'll say is the median. Then I want to find the middle of this section, would be right there, and the middle of this section, which would be right here. So we have 1 part, 2 parts, 3 parts, 4 parts. This would be considered Q1, or quartile 1. The median is right there. And this is Q3, quartile 3. So you get your 4 parts. This number here and this number here are really important. And the median also, we've done some of that. You need quartile 1. You need this number and this number because you're going to use those to find something called the interquartile range. So the range of something would be from this end to this end. That's your full range. But if you have quartiles, you have from here to here, you might just want the range from there. That would be your IQR, interquartile range. The whole thing is your range, but this is your interquartile range. Okay? So, let's look at, I'm going to move that all to the side there, make this bigger. So, say we have this set of data from 0 all the way to 8. The range of that, and we know it's in order, 0, 0, 1, 1, 2, 2, 2, 3, okay, all the way from least to greatest. So the range of this is 8 minus 0, which is 8. So I have a range of 8. But now I want to find the median. And the way you find the median is, I'm going to do it, kind of take that one away, take that one away, take that one away, take that one away. Take one over here, one over here. So I've done 3 on each side. Do another one. Now that's 4 on each side. Another one. That's 5. I'm getting closer to the middle. Got to be fair on each side. So that's 6 on each side. do another one over on each side, so that's 7. So now I'm left with these two. Now the way you find the median is you add those together, 7, divide by 2, so my median is 3.5. All right? But now, that's the median. The median is right here. That's the median. Now, I want to find the median of the first half. So I have this to here. This is the first half. I've got the median of the whole thing is right there. But the median of this, so I go, take one of these away, take one of these away. One of these away, one of these away. One of these, and I'm left with that. So 1 plus 2 is 3, divided by 2 is 1.5. So that's quartile 1 is 1.5. Now, I got to do the same thing over here. Take one away, one away, one away, one away, one away, one away. Then I have 6 and 7. 13 divided by 2 is 6.5. All right, so we have this whole set, a range of 8. Now we could find the interquartile range, and the way you do that, it's from this right here to this right here. So it'll be 6.5 minus 1.5. And that would be 5. So the interquartile range is 5. The range of the whole thing is 8. All right. This is really hard to teach over a video like this. I really wish we were in person. But let's keep going. We're just going to do a bunch of examples, and I think you'll start to catch on, okay? But median is the key. I would say you need to break a set of data 4 ways. You need to know the median, which cuts it in half, and then you need to know the median of both halves. Okay? I think that's as basic as I can explain it. All right, let's go on. Now, why would you want to find the interquartile range? The reason why you would is because sometimes with data, you might have data like 2, 3, 5, 6, 102. An outlier is something that seems odd. It's much greater or much less than what you would think in the set of data. So this 102 seems really strange. And the way you would know that as an outlier is once you find the interquartile range, then you could figure out if it truly is an outlier or if it's pretty close. Okay? So, an outlier is a data value that is either much greater, or much less than the other values in a data set. If a data value is more than 1.5 times the value of the interquartile range beyond the quartiles, it is an outlier. Okay. This is a lot. So let's get into a problem, and I'll help explain some of this stuff. Okay? Okay, we're going to practice all this stuff. It's a lot to think about. So right now we have wind speeds average wind speeds of several cities in Pennsylvania on this table. So if we go to Allentown, it's 8.9. Erie, it's 11. Harrisburg, 7.5, and so on. So we have all these cities and their average wind speeds. Okay, so we got our data. Now we want to know what do they want us to find out. So let's start with this first one, and it says range. If we want to find the range of the data, we have to subtract the smallest from the largest. But to do that, we have to put them in order. Numerical order from least to greatest. So let's start. I can see that I have an 8 something, 11, a 7, 7, 9, 9, 7. 7 is the smallest, and I'm going to find out which one's the smallest. Looks like 7.5. Okay. And then after that, I have 7.6. And after that, I have 7.7. And I think that's all of my 7s. Now let's look at 8. I have a 8.9. That's the only one. 8.9. Now I get some 9s. I have 2 of them. 9.0 and 9.5. Okay, and then I have 111. Oops. 11.0. Okay. So now, to find the range, I'm going to do 11 minus 7.5. And when I do that on my calculator, it equals 3.5. So I got the range. That's the range of the whole data set. But we want to go a little smaller. We can go smaller than that. All right, now, question B says, find the median and the first and third quartiles. Let's just take one step at a time. Let's find the median, okay? Median is the middle. So I'm going to take one off that side, one off that side, one off there, one off there, one off there, one off there. So I did 3 off each side, and it leaves me with this one right here. There's my median. Cool, the middle. So my median is 8.9. Now, to find the first quartile, first and third, the first is you take this half, and I want to find the center. So now, I take this one off here, and I take this one off here, and it leaves me with this one right here, which is my quartile 1. Now, so the first quartile is 7.6. Now I want the third one. Second quartile would be your median, it's the middle. So now I got to go from here to here. I take that one off there, I take that one off here, on each side, and it leaves me with 9.5, and that's my quartile 3. Okay, 9.5. So you can kind of see I broke it up into 4 sections. From the beginning to here, this is one part. From here to here is a second part. Here to here is a third part. And here to here is a fourth part. I just kept I cut it in half, got the middle, and then I got the middle of the first half and the middle of the second half. So it's in 4 spots. Now, this is important because if I want to find the interquartile range, I look at the quartile 1 and quartile 3. Remember, the whole range was the greatest, the big one here, take away the small one, and that got me 3.5. But now I want the interquartile range, so I'm going to take 9.5, and I'm going to take away this one, 7.6, and that leaves me with 1.9. So the interquartile range is 1.9. the range of the whole data set is 3.5. So now we need to know this 1.9. We need to know the interquartile range to see if there are any outliers. See if there's anything so much greater than what makes sense or that fits in the data, or something that's so much smaller. And you can only do that when you have this interquartile range. The way you find outliers is you take your interquartile range and you times it by 1.5. It'll always be times 1.5. This time, the interquartile range was 1.9. So 1.9 times 1.5. Let's see what we get here. 1.9 times 1.5 gets me 2.85. Okay? So that number's important because what I'm going to do with that is to find the outliers, I'm going to take that number and I'm going to add it to Q3, and I'm going to take Q1 and subtract that number. So I'm going bigger here and I'm going smaller here to see if there's any outliers. So quartile 3 is this 9.5. 9.5 plus 2.85 equals 12.35. So anything 12.35 or bigger would be considered an outlier. Well, your biggest one is 11 here, so no outliers there. Let's go to the other side. So I'm going to take this 7.6. This time I want to go smaller. 7.6 minus 2.85, and I get a 4.75. Okay, anything there or less is an outlier. But we have 7.5 here, so it fits within the range. Okay, so are there any outliers? No, none. Whew. Okay, so I did a lot with this set of data. I put it in order. I divided it 4 ways by finding the median first, and then I took the first half of it, found the median of that half, which was quartile 1, and then I found the median of the second half, which was quartile 3, and when I did that, I could take quartile 3, that median, minus quartile 1, that median, to find my interquartile range. And when I did that, I times that by 1.5, so that I got this 2.85, added it to my quartile 3, see if anything was too big, and I subtracted from quartile 1 to see if anything was too small. Okay. This is a lot of stuff to think about and remember. But the way we'll get this is we'll be doing example after example. We're probably going to work on this section for the rest of this week. Okay, let's do another one. All right, here we have something. It says the heights. I'm going to highlight things I think are important. The heights of several types of palm trees, so these are heights, are 40, 25, 15, 22, 50, and 30. The heights of several types of pine trees, okay, I got something different here. Pine trees, heights of pine trees are those numbers, okay? So I have 2 sets of data here. I have heights of palm trees, 40, 25, 15, 22, 50, 30. And I have heights of pine trees, 60, 75, 45, 80, 75, and 70. What it wants me to do is compare and contrast the measures of variations of both kinds of trees. So let's find the ranges and all sorts of things. So I'm going to do the palm trees in yellow. So I first want to put these in order. I have a 15. Then I have a 22. Yep. 22. Oh, I have a 25. 25. Then I have a 30. 30 right there. Then I have a 40. And a 50. Okay. So I can get my range. Range equals 50 minus 15. And 50 minus 15 is 35. Now, I want to find my median, which is the middle. So I take one off the end, one off that end, one off this end, one off this end. Ooh, and I have 2. So now I'm going to take 25 plus 30. That equals 55 divided by 2. And that gets me my median of 27.5. So my median is 27.5. Okay, so far so good. Now, we want to find quartile 1, quartile 3, and the interquartile range. Fun stuff. So, quartile 1 is you take from here to here, and you find the center. So, take 1 away here, take 1 away here, and it leaves me with 22. So 22 is Q1. And now I have this section over here. I take 1 off this end, 1 off this end, and it leaves me with 40, which is quartile 3. 40. Now the way I find the range of that is 40 minus 22, and my interquartile range is 18. Okay. So that's all the stuff we need to know for the palm trees. Let's go to the pine trees, shall we? So let's put them in order. Okay, let's put them in order. We have a 45 here. I think that's my smallest. Do we have any 50s? Nope. Do we have 60? Yep, a 60 there. Then, oh, I have a 70. 75. 75. And 80. Okay, now let's find the range, the median, quartile 1, quartile 3, and the interquartile range. Exciting stuff, yeah. The range is going to be the greatest minus the smallest. 80 minus 45 equals 35. Well, that's interesting. They both have the same range of 35. But I'm going to guess they have different medians because they have a lot different numbers. So let's find the median of the pine trees. So I take 1 off this end, 1 off here, 1 off this side, 1 off this side. Oh, and then I'm left with 2 in the middle. So I do 70 plus 75 divided by 2 equals 72.5. That's my exact middle, 72.5. Yeah, that median is a lot different. It appears to me that these pine trees are a lot taller. Okay, Now, once we found the median, we've got it in two sections. One over here, one over here. We have to find the median of both sections. So let's find coordinate 1. Okay, I'm going to take this one off here, this one off here. It leaves me with this right here. That's Q1 is 60. And now we go over to this section. I have this one over here. Take that one away, take that one away. Leaves me with the center of 75. And I have to take quartile 3, 75, minus quartile 1, which leaves me with 15. So the interquartile range is 15. So what this tells me is the range of the tallest to the shortest trees is about the same when you're talking about palm trees and about the same when you're talking about pine trees. But pine trees are much taller. 72.5 compared to 27, 60 compared to 22, 75 compared to 40. So much taller. But again, the interquartile range, 18 and 15, is similar. So the ranges of these are similar. So they can compare within this data set. The full range, it's like 35. It's the same. And if you do the interquartile range, you see that it's pretty close too. And then you could use this interquartile range. You times it by 1.5 to see if you have any outliers. But we're not going to do the outliers right now. We just wanted to kind of compare these pine trees and these palm trees. Okay, let's move on. All right, here is what I will say. You could practice this by pausing the video, and you look at this table. It is the number of golf courses in different states. And so you're going to find the range, you're going to find the median, the first and third quartiles, you're going to find the interquartile range, and if any outliers are in the data. So this is a lot. I would pause the video, give it a try. I bet you don't get all of those sections. It's a lot to think of. This is just an introduction to this, but see what you can get. I'm thinking you'll get the range. Let's see here. We'll go here. I think you'll get the range. And I hope you get the median because we've talked about that. Now the new thing is finding the first and third quartiles, but it's just the medians of the first half and the second half, so you can try that. And then to find the interquartile range is just to subtract the first quartile from the third quartile. And then you might get stuck on this outliers. That's kind of a hard one. But see what you can do. Try it, pause it, do it, and then come back and I will do it, and you can see how you did. Okay, let's see what you got. Let's do the range first. But I have a data set, so I want to put them in numerical order from least to greatest. So I see I have thousands. I have 4 that are in the thousands. Those are big. So I'm going to let those go for now. I have a 400, a 500. So there's 400, 437. Looks like I have 2 that are in the 400s. And 437, 430. Oh, you know what? I got to give myself a lot of space here. 437. That one's pretty small. Then a little bigger is 456. Okay. Now I'm going to look at 500s. There's only one 500, which is 513. Okay. Now I'm going to go a little bigger. 650. 650. Okay, now do I have any other 600s? No. Do I have 700? No. Do I have 800? Yep, I got one 800. 893. Any 900s? Just one. 954. Now I'm in the thousands. I see that I have 1100, 1400, 1038, and 1018. This is my smaller one. 1018. Then I go a little bigger with 1038. Then this one is 1117. And my final one is 1465. Whew. That's a lot of work in itself. But I got them all in order, and you might want to even check it. 1, 2, 3, 4, 5. There's 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. Make sure they're getting bigger as you go. And they are. Okay, now I want to find the range. So I take the big one, 1, 4, 6, 5. Subtract the little one, 437. And I get 1465 minus 437. I get 1028. So my range of the data is 1028. Cool. Now let's go to a little trickier. Let's find the median, the middle. I'm going to take one off that end, one off here. Okay. So I want to take the same amount off each end going toward the middle. There's my third and third. Here's my fourth and fourth. And now I'm stuck with these two. Okay? So now I add them together. I'm not stuck with them, but I have 893 plus 954. That equals 1847 divided by 2 gives me 923.5. So my median is 923.5. That's the exact center. Okay. Now I want to find the first quartile. So I take this first half to get Q1. And the way I'm going to do that is I'm going to take this one away and this one away. This one away, this one away. And it leaves me with this one. There is my Q1. First quartile is 513. Cool. Now, let's do the second, or the Q3, quartile 3. I take this one off here, this one off here, this one, and I'm left with 1038. And that is my Q3. Okay. Now, the way you find the interquartile range is you find the range of those third and first quartile. So you take 1038 minus 513. And you get minus 513 equals 525. So my interquartile range is 525 number of golf courses. All right. The last thing we're going to do, once we have that interquartile range, we can figure out if there are any outliers. And the way you do that is you take your interquartile range, you take 525, and you times it by 1.5 or 1.5. So let's do that, times by 1.5, and I get 787.5. Now that's the number I'm going to use. I'm going to add this number, add it to my Q3, and I'm going to take this number away from Q1. Let's go bigger first. So I take this number and I add it to 1038. So plus 1038, that gets me 1825.5. Anything above there is an outlier. Well, my biggest is 14. Are there any outliers there? No. None on the big side. So let's go to the small side. I take my quartile 1, 513, and I take away my interquartile range times 1.5, 87.5, and I get negative 274.5. Okay? My smallest one is a positive 435. There's nothing over here. So I would say there are no outliers. Okay? Hopefully you did okay on that one. Or you're starting to understand this, starting to get the idea of taking a set of data, get the big range, then break it up into 4 parts where you get the median, which is exact middle, and then you get the median of the first half, which is Q1, and the median of the second half, which is Q3. You subtract those to get your interquartile range, and then you times that by 1.5, and you either add it to your quartile 3 to see if anything's outliers on the big side, or you take quartile 1 and subtract what you got to see if there's anything on the little side. That is a mouthful, a lot to think about. We will practice this a lot. This will come into play when you start doing a lot with statistics and data sets, and especially for those who are sports fans. If you think about all of the numbers that go into that, and the NFL draft is tomorrow, so people are looking at all the metrics and numbers and the outliers and the averages and the ranges, and numbers are huge. And so these are important things to know how to do. Okay? So I'm going to give you 2 problems that I want you to try. I'm going to put the problems, take pictures of them, put them right into the Google form. Go into the Google form, you'll see the problem, put the answer on, see what you get, see if you can do it, and then we'll keep working on this. We're going to practice it more on Friday and even into next week. All right? So, good luck.